This video, I'm going to work exercise 17.3. It's on page 17-35 in your textbook. Down here in the instructions, they want us to compute Stefani's total standard cost per unit. And the standard cost would be the sum of direct materials, direct labor, and manufacturing overhead. So I don't have anything in my Excel file yet, but the standard cost per unit is going to be equal to the unit direct material cost plus the unit direct labor cost plus the unit variable overhead cost. And so we're going to add those three together. So I need to have a unit direct material cost here, and then a unit direct labor cost here, and then a unit variable overhead cost here, and then we'll just have the total here. And so we'll just put those in as we go, and then we'll add them up when we get to the end here. And for all of these, we're going to mark these as accounting, and we're going to take them to 2 decimal places and put dollar signs on them. Okay. So let's go back to the problem. Let's talk about direct materials. So Stefani Company's gathered the following information about its product. It's trying to establish standard cost. So the direct materials, each unit of product contains 4.5 pounds of material. So obviously that's going to be factored in. The average waste and spoilage per unit produced under normal conditions is 0.5 pound. So this is something that's very common in manufacturing, right? Anytime you're making something with materials, there's going to be a little waste, right? If you go into the kitchen to bake some chocolate chip cookies, you're going to need to get some flour. And you're going to waste some flour, right? Not every little grain of flour is going to make its way into the batter. You might spill a little on the counter. And even if you don't, it's not all going to mix into the batter. There might be some up on the rim or wherever. And so you may not, you're not going to get 100% of that flour in there. And so this is very common. We understand that when we manufacture something, we're going to have a little bit of waste. And so we can't hold employees to a standard that doesn't allow them to have any waste or ever make any mistakes. That's not realistic. We want this to be realistic because we want it to be accurate. So accuracy says when humans are making something, sometimes they're going to mess up. There's going to be a little bit of waste. We need to give them a little cushion there. So the product itself contains 4.5 pounds of materials, but the average waste is 0.5 pound. So that means we expect to use 5 pounds of material for every product we make. 4.5 will actually make it into the product itself, and the other 0.5 pound will be waste or spoilage or whatever's going on there. So the amount of materials that we expect to use per unit are 5 pounds, not 4.5. So make sure you're looking at this closely when you're doing practice problems. Now, materials cost $5 per pound. But Stefani always takes the 2% cash discount all of its suppliers offer. Suppliers will often offer a discount in order to give you an incentive to pay your bill early. And 2% is very common. So what that means is that even though the materials cost $5 per pound, Stefani is not going to pay $5 because Stefani always takes the 2% discount. So if Stefani is getting a 2% discount, that means Stefani is only paying 98% of the $5. So 98% of the $5. Now, the other thing that Stefani is paying for is freight. Freight is shipping. So if you have to pay for shipping, that's part of the cost of the materials. And so the cost average 25 cents per pound. So when we come over to do the direct materials calculation, we're going to have over here, I'm going to have pounds used are going to be 5. And then cost per pound is going to be equal to $5 times 98% because Stefani always takes the 2% cash discount plus 25 cents per pound that Stefani pays for shipping. And so that's going to come out to be $5.15 per pound. So the unit direct material cost is going to be equal to the pounds used times the cost per pound. And here we'll get a total of $25.75. So notice it's not as simple as it might seem. It might seem that, oh, they use 4.5 pounds and it costs $5 per pound, so we should just take 4.5 pounds times $5 per pound. No, it's not that simple, because we're not talking necessarily about the amount of pounds that are actually going to go into the product, but the amount of pounds of materials that you're going to use in the production process. And that has to account for spoilage and waste and so on. And the cost per pound has to take into account any discounts that we might be taking advantage of. And if we have to pay for shipping, that also has to be added in. So watch this in your practice problems and let me know if you have questions about any of the details. Now let's go to direct labor. Direct labor, each unit requires 2 hours of labor. However, setup, cleanup, and downtime average 0.4 hours per unit. So for instance, our employees are not going to be working nonstop. In other words, when they first get there in the morning, they're going to have to set up. And at the end of the day, they're going to have to clean up. And they're not going to do that for free. We're going to pay them for that. So we're going to have to include that in the total manufacturing time. Further, there's going to be downtime, right? Because they may have to go to the bathroom, or maybe production hits a snag and they're standing there with nothing to do for a few minutes until production gets rolling again. There's going to be downtime. And so we've got to factor that in as well. So setup, cleanup, and downtime average 0.4 hours per unit. The unit itself requires 2 hours of labor. So that means that the labor we're going to spend on each unit is actually 2.4 hours per unit. So again, it's kind of like the materials. It's not just simply the amount of hours that are going into the unit itself, but it's the total number of hours that we spend to get a unit complete. And that would include things like setup, cleanup, and downtime. So 2.4 hours is the number here. The average hourly rate of Stefani's employees is $12. However, payroll taxes, that's FICA to you and me, and unemployment taxes, and fringe benefits like sick pay, vacation pay, 401k matching, whatever it is, are an additional $3 an hour. So when you figure out what you're paying your employees, it's not just what their hourly rate is, but it's their total compensation, which could include things like employer-provided health insurance, 401k matches, sick pay, vacation pay, anything like that. That's going to count as a fringe benefit, and that's going to have to be factored in. So when I come over here, the number of hours used is going to be 2.4. And the cost per unit, or the cost per, it says the average hourly rate. So the cost per hour is going to be 15. It's going to be the $12 per hour plus the $3 for payroll taxes and fringe benefits. So my direct labor cost is going to be equal to 2.4 times 15, or $36 per unit. My variable overhead says it's $7 per direct labor hour. So all I got to do for variable overhead is take the hours used, 2.4, and multiply by $7 per hour for variable overhead, indirect labor, indirect materials, things like that. And that's going to give me $16.80. And the total unit cost here is $78.55. So that's the answer to the problem. So again, if you need to go back through this video, it's relatively short. You can go through it a couple of times to make sure that you get all the details in this problem. And again, if you see details in your practice problems you're not sure what to do with, or you look at the solution and you're not sure why you include them or why you leave them out, be sure just to let me know.